To prove that something is an inverse algebraically, then we have to prove that f of g of x equals x, and so does g of f of x equal x. So I'm going to do the first one. I'm going to start in the middle here, and I'm going to write g of x. So 2x plus 1 over x minus 1. And I want to find f of that. So I'm going to rewrite f, and everywhere I see an x, I'm going to put parentheses, parentheses. In that parentheses, I'm going to put a 2x plus 1 over x minus 1, 2x plus 1 over an x minus 1. So from here, I'm going to make these both fractions. I need a least common multiple on the top. The least common multiple is x plus 1. So I need an x plus 1 on the top and x plus 1 on the bottom. When I do that, I get 2x plus 1 plus x plus 1 all over x. Oops, that should be minus. So let's go back and change this one right here. That should be a minus. So on the top, I'm going to combine my, let's go ahead and do the bottom and then we'll combine like terms. Again, my least common multiple is x minus 1. So I need it top and bottom. So on the bottom, I have 2x plus 1 minus 2x minus 1 all over x minus 1. When things are similar top and bottom, like the denominators, those can cancel. So on the top, I have 3x plus, 3x, because those cancel. When I distribute this, so I have 2x plus 1 minus 2x plus 2. Those will cancel, and I get 3, which means this equals x. So a little messy, but we'll get to it. All right, the next problem, we're going to do the same thing. I'm going to start with f of x, which is x plus 1 over x minus 2. I'm going to find g of that. So g is, let me do it on another page. 2x plus 2x plus 1 over x minus 1. And in there, I'm going to go ahead and put f, which is x plus 1 over x minus 2, x plus 1 over x minus 2. All right, the top. I need a least common multiple, which is x minus 2. So the top will need an x minus 2, and the bottom will need an x minus 2. When I do that, I get 2x plus 1 plus 1 times x minus 2 all over the least common multiple of x minus 2. The bottom, if I make this a fraction, I need to do the same thing. So the top, I get x plus 1 minus x minus 2 all over x minus 2. So I can even simplify this a little bit easier. If I distribute this, I get 2x plus 2 plus x minus 2 all over x minus 2 divided by, distribute this negative, I get x plus 1 minus x minus 2 over x minus 2. So if we do this, dividing fractions is easy as pie. Flip the second and multiply. So let's cancel that. So I get a negative 1. So this is a multiplication. We won't make it look like an x. Here I have 3x over x minus 2. I feel like something has to be wrong here. When I distribute, this needed to be a plus. So this would be plus 3. Oops. I flipped it. So this is still x minus 2. Excuse me. And this is plus 3. So now I cancel. That cancels with that. That cancels with that. And I'm left with x. Therefore, I've just proven that both of those are inverses of each other.